Okay guys, the first part here proved that 1 plus omega squared equals 0. I've proven that a couple of times now, most recently in 1959, so you can look at that video if you want to see that. On to the first part here. Show that this equals this. So if we just group things together, a and a is 2a, and then take out the omega, and you're left with b plus c, and then take out the omega squared, and you're left with b plus c. Take out the b plus c, and you're left with omega plus omega squared. But omega plus omega squared is minus 1. So you have 2a minus b minus c, which is what you're supposed to get. Now, the next part here, you want to factorize this. So it's a sum of cubes. X plus y cubed is equal to x plus y, which we know, times x squared minus xy plus y squared, which we don't know. We don't know x squared, y squared, or x times y. So that's what we should work out next. So thinking of this as x, you have a plus omega b plus omega squared c squared. So that's a squared plus omega ab plus omega squared ac plus omega ab plus omega squared b squared plus omega cubed, which is 1 bc plus omega squared ac plus omega cubed bc plus omega 4 c squared. Can we clean that up a little bit? I think we might be able to. So that's a squared omega 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 plus bc plus bc again. That seems a little bit suspicious, so we better check that our multiplication worked out. A by a is a squared. A by omega ab is omega ab. A by that one is omega squared ac. Then omega b times a, omega ab, omega squared b squared, omega cubed bc, omega squared ac, omega cubed bc, and then omega 4c squared. Yeah, no, it looks like it checks out. So a squared bc plus omega ab plus ab plus c squared plus omega squared ac plus ac, omega squared is there and there and there, ac, and then b squared. Okay. So I can get rid of the omega squared. I could say it's minus 1 minus omega, but that might not be too helpful at the moment. But the next bracket to do is a plus omega squared b plus omega c squared. Okay, let's have a look at that one. So that would be a squared plus omega squared ab plus omega AC plus omega squared AB plus omega 4B squared plus omega cubed BC plus omega AC plus omega cubed BC plus omega squared C. So that would be A squared plus BC plus BC plus omega AC plus AC omega AC omega AC. There should be a third omega AC. Oh, B squared there. Plus omega squared AB plus AB plus, now that should have been a C squared, shouldn't it? C squared. Okay, and now we have to multiply them together. So that's A plus omega B plus omega squared C times A plus omega squared B plus omega C. So that's A squared plus AB omega squared plus omega AC plus omega AB plus omega cubed B squared plus omega squared BC plus omega squared AC plus omega cubed BC, no, omega 4 BC, so that's omega BC, omega squared times omega squared, and then omega cubed C squared. So that's equal to A squared plus B squared plus C squared plus omega AC plus AB plus BC plus omega squared AB plus BC plus AC. A squared, yep. AB, yep. AC, yep. AB, yep. B squared, yep. BC, yep. AC, yep. BC, yep. And C squared, yep. Okay, so now we'll need to calculate x squared minus xy plus y squared. So x squared minus xy plus y squared. So add the first two and subtract the third one. So let me highlight in green what I'm adding. So it's this one here plus this one here minus this one here. So let's see, a squared plus a squared minus a squared, that's a squared. BC plus BC plus BC plus BC, so that's 4BC. And then minus B squared minus C squared. Okay, plus omega AB, 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 AC, AC. So 2AB plus 2AC plus B squared plus C squared minus an AC, minus an AB, and minus a BC, plus omega squared AC, AC, well that AC will cancel, AB, AB, that AB will cancel. So you're left with AC plus AB, AC, AB minus BC plus B squared plus C squared. AC, AC, AB, AB, B squared, B squared, C squared, C squared minus BC minus BC. These two brackets are the same. That's really nice. That's really nice. So now what I can do, I can say this is equal to A squared plus 4BC minus B squared minus C squared plus AB plus AC plus B squared plus C squared minus BC, omega plus omega squared, which is minus 1. So let's see what we're left with now. A squared and then minus B squared minus B squared, so minus 2B squared minus 2C squared, 4BC plus another BC, so that's plus 5BC, minus AB minus AC. So let's see, A squared, yeah, and then minus B squared minus C squared, minus B squared minus C squared, yeah, okay. And then 4BC, so plus 5BC minus AB minus AC. Okay, so now if I make some space on the top, let's see what I get. Okay. Let's see what I get. So remembering that x cubed plus y cubed, that's equal to x plus y, which we were given in the question, or we had to prove earlier. So let me just grab that again. That's 2ab, 2a minus b minus c times a squared minus 2b squared minus 2c squared plus 5bc minus ab minus ac. Right. So let me have a look here. A squared minus 2b. So it's looking not too bad. I think I might be right. Let me just check something here. Okay. Now I can can possibly factorize it a bit more. Possibly factorize it a bit more. 2a. Yeah, maybe I can factorize this a bit more. Let's see. So that's 2a minus b minus c. So let's see if we can get an ABC and an ABC here. A, B, C, A, B, C. Well, to get the a squared, they both have to be 1s. And then to get the minus 2b squared and minus 2c squared, going to need to have a 2 on the b and on the c. Could put a 2 on this b and a 2 on this c maybe. Let's try minus 2b plus c, and then let's try minus plus 2b minus 2c. Let's see if we multiply that out, what do we get? So a by a is a squared. Okay. Actually, you know what? We'll multiply it out and check that it works. We might have to change the numbers and the signs around, but we can see what happens. There's not going to be too many variations. Okay, let's see. A by a, that's a squared, plus ab minus 2ac minus 2ab minus 2b squared. Alright, let's see, where was I? A squared plus ab minus 2ac minus 2ab minus 2b squared plus 4bc plus ac plus bc minus 2c squared. So that's a squared. Where's my b squared? Minus 2b squared minus 2c squared, 4bc plus a bc, that's 5bc, ac minus 2ac, that's minus ac, and what have I got left? ab minus 2ab is minus ab, a squared minus 2b squared. Yeah, so after all that, we're left with 2a minus b minus c times a minus 2b plus c times a plus b minus 2c. That's the factors there. It's that times that times that. That was the hardest complex number question I've ever seen. I don't think I've seen one ever as difficult as this. Can't believe how tricky that was. I'm sure there must have been a better way to do it. This factorization here at the end is a little bit tricky. I got lucky here Well, I mean, you kind of know the A is, and the C is, and the B is. The only issue is the signs, really. But you could tweak the signs here until the sum works out, so it's not really too big of a deal, I guess. But anyways, that's the answer there. Quite amazing, really.